glad to be here today. I'm Lucas. I'm based in Brazil, and I'm a web developer here at Evenness. With a background in advertising, I always try to apply my design and visual skills to create a functional and visually appealing to the web applications. So that's a little bit about me. Let's get started. First of all, we need to understand the difference between Web2 and Web3. Let's dive into Web2, often referred to as the social web. Web2 emerged in the middle 2000s and fundamentally transformed the internet as we knew it. It introduced the concept of user-generated content, collaboration, and sharing, which revolutionized the way we communicate and access information. So platforms like Facebook, Twitter, and YouTube emerged, enabling individuals to not only consume, but also contribute content to the digital realm. Web2 empowered us to be both consumers creators, fostering a sense of community and interactive on a global scale. Web2 was marked by the rise of social networking, where people could connect with friends and family, share their thoughts, photos, and videos, and also participate in online discussions. It gave rise to the sharing economy, which we're going to be talking a little bit later, enabling peer-to-peer collaboration in various fields, from ride-sharing to accommodation. Web2's impact was immense, bringing people together in ways never before possible. But it was not only without its issues, such as concerns about data privacy and centralization of a few tech giants. Now talking a little bit about Web3. Web3 is the decentralized web that leverages blockchain technology to provide a more transparent, secure, user-centric experience. Unlike Web2, which is characterized by centralized platforms and intermediaries, Web3 aims to decentralize control and data ownership, putting users back in charge of their digital lives. Web3 is built on the principles of decentralization, blockchain technology, and the idea that individuals should have ownership of their data. Blockchain, with its inherent transparency and immutability, Web3, ensuring trust and security. In a Web3 world, users have control of their data and digital identities, allowing them to participate in online activities without sacrificing their privacy. So that's Web2, the social web, brought us closer together through user-generated content and collaboration, but it also raised concerns about data privacy and centralization and this kind of stuff. Web3, on the other hand, the decentralized web represents a new era in which blockchain technology empowers users to have more control over their online lives, while promoting transparency and security. So moving on to the next slide, a shift in how data is managed and controlled on the internet, represented by the transition from Web2 to Web3. So let's talk a little bit about that. In the Web2 era, data is predominantly stored on centralized servers. What this means is that companies have a substantial control over user data and the platforms where this data resides. When you post a picture, for example, on a social media platform, or you store your files in the cloud, you are entrusting your data to these centralized entities. While this model has brought us tremendous convenience and connectivity, it has also raised concerns about data privacy and security. We've witnessed several instances of data breaches, misuse, and concerns about how our information is being managed without our explicit consent. On the other hand, in Web3, data is stored on decentralized networks, marking a significant departure from the centralized data model. This shift represents a sea change in the way that is controlled and owned. Users are given true ownership of their data and digital assets. And this is made possible through the innovative technology of blockchain, as you guys might be aware. So, for example, here we have the take non-fungible tokens, or NFTs, for example. NFTs are a prime illustration of digital ownership in the Web3 landscape. NFTs are unique digital assets, often art, collectibles, or digital content. Because they're based on blockchain technology, NFTs allow users to have indisputable proof of ownership. When you own an NFT, You have the digital certificate of authenticity that is recorded on a public blockchain. You have true ownership of the digital, which can be transferred, sold, or showcased across several platforms without relying on a centralized authority. As I said before, the monetization and value transfer across the web. So this slide basically encapsulates the profound transformation we are witnessing in the way the internet handles monetization and the transfer of value. So in the Web2 era, which has characterized the internet for quite some time, monetization has primarily been ad-driven. Digital platforms and service providers have leveraged user data to deliver target advertisements, effectively controlling and benefiting from user engagement. While this ad-driven model has sustained the free availability of many online services, it has also raised valid concerns about data privacy, as well as the concentration of power and profits in the hands of a few tech giants. On the other side, in Web3, there is a fundamental shift towards direct peer-to-peer transactions, eliminating the need for third parties. This decentralization is by blockchain technology, which underpins cryptocurrencies and smart contracts. As a result, users can engage in transactions and exchange value without relying on centralized platforms. Cryptocurrencies play an important role nowadays because it enables seamless value transfer within the Web3 ecosystem, with the cryptocurrencies per se become quicker, more transparent, and less susceptible to manipulation. Users are no longer confined by the limitations and fees imposed by traditional financial institutions. This creates a more efficient landscape for the digital transactions. One of the most exciting aspects of Web3, in my personal opinion, is that it enables users to earn directly from their contributions. Through tokenized rewards, users can be compensated for their participation in online activities. This extends to content creators, artists, developers, and virtually anyone who contributes value to the online space. Web3 empowers individuals to benefit directly from their creative efforts and participation in digital communities. Okay, so that's a little bit about the monetization and value transfer across the web. And now we can talk a little bit about the trustworthy web and its crucial differences in how trust and security are established and maintained in Web2 and Web3. So in the Web2 era, trust often relies on centralized models, right? Such as platforms' reputation. We've grown accustomed to putting our faith in well-established online platforms, trust to safeguard our data and provide secure services. That's what we hope, right? However, the system is not without its flaws. Web2's centralized trust models make it vulnerable to centralized points of failure. When these platforms are compromised, whether through data breaches or security issues, the trust we've placed in them is shattered and our personal information may be at risk. Let's transition to the promising realm of Web3, where trust is built on cryptographic verification rather than reputation, as you saw on Web2. Trust is established through transparent, decentralized consensus mechanisms that underpin blockchain technology. The blockchain, with its inherent immutability and cryptographic security, creates a foundation of trust that is unbreakable. Users can verify, not just trust, thanks to the transparency and security provided by the blockchain technology. One of the most significant advantages of Web3 for me is that it enhances the security it offers. With cryptographic verification and decentralized consensus mechanisms, the system becomes far more robust and resilient to attacks. Users can have confidence that their data and digital transactions are secure and immutable.
Clear also. Today we have like decentralized version of it where user is in control of sharing whom they want to share, etc. But if we have data completely broken up and shared between different devices, screens and different interfaces in general, because of course today more than ever you have multiple variants of different screens, starting from smart mobile phones, smart TVs, smart fridge, smart I don't know, lamps, etc. It's really crucial and important that your brand you want to build be consistent and be recognizable everywhere. Thanks to that, and because of that, we ended up with some of the most efficient solutions so far in building consistent unified interface or unified design for an interface, which will be helping all the users and all other customers basically to recognize and understand that content and interface you are they are interacting with is basically from specific companies for specific purpose, of course. That's more than ever related to trustworthy and relationship that you can buy something from Amazon, but you will not buy something from Amazon / something else, right? Some other brand which mimicking the Amazon, etc. So from that perspective, it's really important that we have easy to manage, easy to build, efficient and relatively fast way and process how to get from all over the place, from all devices to single unified, strong brand through different devices. And that is basically atomic design. What they're trying to do in a nutshell is to basically simplify the whole interface. If you remember how Amazon, for example, looks like, or any other e-shop, etc., you really know that there is a bunch of different things, and those bunch of different things needs to be usable, understandable, and of course used in the same way. No matter is it a super big screen like I don't know, a 27-inch monitor on your desk, sitting on the desk, or super small like smartwatch, smartphone, or even, as I said, smart fridge. So how we can simplify the process for developer and designer, and also build screens and interfaces consistently through all the devices, right? How was all that was built previously? One of the UI designers will build first few pages in Photoshop, and then based on that few pages, they will build another set of pages for contact and those kind of less important pages, of course, products and e-shop and this and that. So those pages will get less attention at one point from designer, but also they will probably figure it out that some of the components is missing. They need to build this button, this title, this. From that perspective, at the end of the process, usually you have at least 20 different pages for one relatively simple website or web app. You would end up with really inconsistent and really different layout comparing to original idea and everything. Instead of starting building one page first, we plan systematize whole component, everything, including the buttons, including the pages, including the headers and everything. And then from that system, these days it's called design system, and there is a bunch of tools supporting building that way. From that systematic approach, imagine like a puzzles, we build more and more complex components, starting from super simple, super easy to understand, super easy to build, like atoms code. As you see from structural complexity of different categories of components, we starting and imitating the natural world all around us, starting from atoms, and then next a little bit more complex components will be molecules, which will usually be combined like a search field, right? The search field has input field, and that input field is one atom button with an icon is other button, and combined together we get search field, which is molecule. This now called search molecule, search input molecule. But also we need to show those results in some the list table, divs, flows, and or the images, and combined together with that input field, because those two are functionally close and together. Then we will get the next level of complexity of components called organisms, right? And from that perspective, we will continue building new, etc., combining them together into a single page. This way, we will use the same button from one page to another page from all other pages, and also all organisms or all templates will contain the same footer, same header, and we will have that kind of consistency. From that perspective, we tend to have like super easy, super simple flow, which we can follow and navigate. And when we need to fix some of the bugs with some of the buttons, it's really, really easy to go back to a specific element where that bug is, which means basically you don't need to duplicate the code anywhere. You just need to use one component, and then that component will be automatically updated all over the place across all components where that small atom was used, etc. So as I mentioned, consistency across multiple platforms. Since we have like one simple atom, that atom will be used not only in web app, it's going to be used also in mobile app, smart fridge app, and everywhere else. And that's also really, really applicable, especially with blockchain and independent small mini apps which can pop up from multiple sites. If you are really decentralized, somebody else can use that data you have and build their own interface, scalable and modular and consistent between different platforms, different apps, etc. And as I said, lazy developer approach, reusable, so you don't need to update one single button on multiple sites, just in one place, and that's it. Then you don't need to spend a lot of time reading where that code could be. So this is that complexity approach, starting from super, super simple, super easy components called atoms, and then multiple atoms combined into molecules, and molecules are basically organisms. And example for that organism could be, for example, footer or header. In footer and header, you have multiple things together, like a navigation menu, main brand logo on top left or in the middle, sign in, sign up buttons on top right corner, etc. Translation if you have multiple languages, etc. Of course, I'm speaking primarily from perspective of web app right now, but it's the same for all other apps. Different distinction between templates and pages is basically in templates, you have all the components you needed for that one single page. For example, if you go to login on Amazon, you will see specific components, specific elements, etc. And those templates has everything they need except data. So why is that important? That's important because now you can play with sides of data. For example, in German is everything a little bit much wider than usual comparing to English, for example. If you add static data to templates or mocked data, called in developer circles, then you can easily test multiple environments, multiple screen sizes, and see is all the data is going to work together, no matter which data is provided, which screen size it's, etc. Only difference is now, instead of using mocked data in previous step for templates, now we use exact data which we will load from one database or multiple databases, or from one of those decentralized storages or wallets, etc. How all other components can be visualized from this perspective. For example, you will have input fields for form, right? But that field will be unifiedly shared between different data. Only main question is which kind of data will be provided. So, for example, if that data is date time parameter or type, then instead of showing just a simple input text field, we will also want to render calendar or calendar picker or date picker or time picker, for example. If we want to field for uploading data or uploading media, photos, pictures, videos, etc., then we will have like differently rendered input field. But that input field will understand based on that data. So not that we just ensure responsiveness and that in kind of safe environment, safe box, so-called, but we also can test with a different type of data. and different type of screens, as I mentioned previously. One of the most primarily screens where your app will be consumed is not anymore the desktop screen with the landscape perspective, 3 to 4 or 69 or 6 and 10, etc. It's mobile. It's definitely mobile. So we definitely need to ensure that all the screens, all the sizes, everything fits nicely and shows and it's usable at the same level, just like in desktop, especially because when you use some of the apps on mobile, no matter is it native app or web app, you don't have the same level of focus just like you have in web apps, right? Because when you have like desktop screen, you usually use that screen from your office or home work space or your own room, etc. And nobody interrupts you. Nobody kind of breaks your focus, breaks your understanding what you're looking for and what you're doing there. But on mobile, it's completely different version of it. On mobile, you are maybe in a cab, in an Uber, right? Driving from one spot to another or on a street, trying to go over the street, etc. So all of it complicates the flow and everything and breaks your focus and makes everything a little bit more difficult. So that's one of the ways, that's one of the reasons why we need nice and usable environment where we can test all the specific needs for our apps, including mobile, including web, including the even smaller devices like watch, etc. And you're already familiar, there is a bunch of different products and in same space, AR, VR, especially VR, really kind of novice and really nice and fresh. Apple decided to come into that space and introduce or innovate on their own. So I see in a couple of years, a lot of people will stop using mobile app. Same environment, the same from brand's perspective is basically we need to have options how to interact with some of the products of one brand, right? Amazon, as I mentioned before. In AR or VR, we will not just use specific screen which is opaque and cannot see through, etc. Now we need to combine that with all around us, right? And there is a different things and different ways how we can achieve that. But the first and foremost, consistency that one brand will look like the same all over the place will also be ensured thanks to atomic design, right? No matter if are you in a virtual game, virtual studio, or virtual office using AR where you can see your other colleagues, this atomic approach will even more be crucial and important. And I'll show you later that some big brands already recognize that need and recognize that necessity. It's also even more important that consistency is shared between devices, between different platforms, and especially between different providers. By providers, I mean blockchain components and blockchain decentralized ecosystem. So how we can implement all that process? As I mentioned, we will start from prototype, what we need to build and how many components we will need for that specific brand, that specific web app or mobile app or decentralized app, and classify those all components into categories that I mentioned before. So from there, first things first, of course, we build atoms, and those atoms got combined to get molecules. But it's not just you build one component and you forget about it. There will be like multiple back and forth to test different sizes, different component layouts, etc. Which means basically that whole that process is iterative. After versions, each of iterations, we will have like better and better and consistent and kind of bulletproof solution to. We will be confident in that interface that will behave the way we want, no matter which device and which screen size we are using. After constructing molecules, organisms, and templates, there will be some tools which we can utilize in our process. But Storybook is used primarily for JavaScript-based applications. JavaScript has multiple frameworks which helps you build single-page applications, but that single-page application is super fast and efficient. So from there, you can use Storybook in React, Angular, and all other frameworks, even aside of it. But in general, it's a kind of safe environment, as I mentioned before, safe sense kind of environment where you can play with each of those components, see the data, see how that is gonna look like, how it's gonna break the layout if data is super big, etc. And of course, building consistent UI is not just thanks to developers; it's also part of designers too. So there is a collaboration that needs to be transparent and also efficient and easy to visualize for developers, because developers are usually not like a visual types of persons, etc. While on the other side, designers sometimes don't grasp whole complexity dependencies from each component to other. From that perspective, these days is better than ever be UI designer in general, because of so many awesome tools which you can utilize and use even without paying a buck. Some of them definitely recommended is Figma. Figma, not just that have only interface elements, they have also variables and some developer functionalities also to help you simplifying the export and conversion from interface to code. UI elements like circles, texts, and images, etc. The other one is to export easily to CSS and any other, of course, programming language. And third component is that you can get automatically out of the box prototype version, where you can connect two different static screens and get a feeling that it looks like and it feels like it's real application already packaged or already deployed and developed, right? So let's go to some of the examples on next slide. So this is how one of those storybook components look like once it's ready and developed. You top of it code with a super simple button, but that button can have multiple options like children, is it active, what theme we are using, and class name which we provided. And of course, in stories below, you can see that one button can have versions of itself. And in this case, we have like 3 different states: default, active, and disabled. The other example on the next slide is also really big brand. I guess you can see from texts here is Audi UI team. So they have also like their own storybook whole library, and all of these libraries is present on the website. And of course, I provided here the links to their specific library. In this case, we have like switcher and a little more complex organism component, which combines multiple components. And of course, you can get the code for it. You can just copy paste, and you'll get the same results once you install the styles and necessary dependencies for this specific theme, for example. Next one is my definitely top favorite design or favorite library. Yes, it's NASA's library. So interact and see and a little play how they build their own websites, other web apps, or mobile apps, or general apps. I think it will be very interesting to see how everything is connected and whole complex interface is basically built from on top of those smaller, super simple pieces and puzzles. In general, we will definitely have a need, even in the future, to still have some kind of interface where our users can interact with. Of course, in last few years, we got a bunch of different products which doesn't include at all interface. By that I mean those kind of voice to command tools like smart speakers, etc. But aside of that one small exception, interface or any other app you would gonna use in the future will be some kind of interface and will contain some kind of interface. That means also for ChatGPT, which is one of the shining examples of generation of AI, that AI also use some interface in order to communicate with you. Even that small, super simplistic interface is still necessary. I fell in love with atomic design last 3 years, and to be honest, I'm never going back. It's that much, efficient, that much more powerful, and super, how to say, simple to use. So yeah, that's in short from us for today.